We are now YouTube live. We'll start in 2 minutes. We'll start in 2 minutes. Students are now joining. So yes, Valay. Am I audible?
Hello, Rohit.
Yes,
Yes,
yes. Let's start.
I hear you.
So I'll just let me introduce. So so गुड इवनिंग एंड जय भीम टू ऑल। मेरा नाम रोहित और आप सभी को स्टेम कोर्स की 15 सेशन में स्वागत करता हूं। जैसे कि आप सभी को पता होगा, स्टेम के ऑनलाइन क्लासेस में हमारे मेंटर्स और एक्सपर्ट्स साइंस, टेक्नोलॉजी, इंजीनियरिंग एंड मैथमेटिक्स में इंटरेस्टेड स्टूडेंट को गाइड करते हैं और सिखाते हैं अपने एक्सपीरियंस के थ्रू। तो आज के सेशंस में हमारे साथ हैं हमारे दोस्त और मेंटर वालय सल्वे, हु इज डूइंग हिज बीएससी फिजिक्स एट स्टोनी ब्रूक यूनिवर्सिटी, न्यूयॉर्क, यूएसए। तो आज आप सभी को बालय एस्ट्रोफिजिक्स के बारे में और ये इंजीनियरिंग के साथ कैसे जुड़े हुए हैं, और स्टूडेंट हु आर इंटरेस्टेड इन एस्ट्रोनॉमी एंड फिजिक्स, उन स्टूडेंट के लिए आगे के क्या करियर अपॉर्चुनिटी है उसके बारे में बताएंगे। सो आई वेलकम बालय टू 15 सेशन ऑफ नालंदा स्टेम काउंसलिंग सेंटर। अवर टू बालय।
Superconductivity.
यस।
And my interest in astronomy began when I was in high school, around fourth and fifth grade, when I read this book called The Time Machine by H.G. Wells, and that sparked my interest in astronomy and astrophysics. And then from there on, I continued my studies within science and math, and I really liked physics, and I was quite good at it. So I thought I will just continue studying physics. And that's how we began with my journey of astrophysics began. So I just start sharing my screen. So today we will be discussing the preparations, expectations, and career opportunities for someone who is interested in physics through the topic of exploring astrophysics. As I said before, I've completed my physics from Stony Brook University, and I had the privilege of working with some of the top professors, and it was a great experience. And then I was able to connect with Nalanda Academy when I heard about the mentorship program, and I was very happy to help few students. And apart from that, as I mentioned before, my research experiences in quantum information and superconductivity. So, for someone who is interested in studying astrophysics, this would help them with preparation and studies, expectations, and career opportunities. तो इस सेशन में हम देखेंगे कि हम कैसे एस्ट्रोफिजिक्स पढ़ने के लिए प्रिपेयर कर सकते हैं, क्या हमारे एक्सपेक्टेशंस होंगे, लाइक हम किस चीज़ के लिए प्रिपेयर होने चाहिए सो दैट वी आर नॉट सरप्राइज बाय समथिंग दैट वी weren't prepared for, और हमारे पास करियर अपॉर्चुनिटीज क्या क्या होंगी. So when it comes to preparation and studies, जब हम preparation और studies की बात करते हैं, the thing that we should keep in mind is that it's a long-term commitment. It is a very long commitment. Once you begin on this path, it's kind of hard to like switch to something else mid-career. And if you start preparing for physics, let's say you pursue Bachelor's of Science in Physics, अगर आप Bachelor's of Science in Physics करते हैं, so it is a little bit hard to get a job with just a bachelor's. तो आपको मास्टर्स करना पड़ेगा, और अगर आप पीएचडी कर दिए तो वो तो it's even better, and you could like go for your postdoc. When it comes to expectations, जब हम expectations के बारे में बात करते हैं, then one thing I often tell my friends who tell me that they are interested in studying physics is that it takes a lot of effort, and it takes a lot of time, and it takes away a lot of resources when it comes to studying physics. It takes a lot of time because to understand one topic, आपको एक topic समझने के लिए you have to read 10 different books, and sometimes it takes time, but uh, it is very fruitful, and इससे आपको मतलब you get a lot of insights on those topics, and it helps you understanding other topics related to those topics as well. And apart from that, एक्सपेक्टेशंस में अगर हम बात करेंगे तो लैब वर्क बहुत सारा होता है. देयर इज अ लॉट ऑफ लैब वर्क, यू हैव टू डू लॉट ऑफ लैब्स. तो बहुत सारी रिपोर्ट्स लिखनी होती है, एंड यू हैव टू मेक श्योर दैट द फॉर्मेट इज करेक्ट एंड ऑल ऑफ योर कैलकुलेशंस आर इन लाइन विद द स्टैंडर्ड्स. जो आप कैलकुलेशंस या जो आप रिपोर्ट कर रहे हैं, इट मैचेस द स्टैंडर्ड्स, वो स्टैंडर्ड्स को मैच करता है. एंड आप देख सकते हैं जैसे हमारे पास है ऑप्टिकल सोसाइटी ऑफ अमेरिका, दे पब्लिश जर्नल्स, एंड देन वी हैव द हाई एनर्जी फिजिक्स सोसाइटी, वो भी जर्नल्स पब्लिश करते हैं. आप उनके पेज पे जाके उनका फॉर्मेट देख सकते हैं. एंड देन व्हेन वी स्पीक अबाउट करियर अपॉर्चुनिटीज, तो व्हेन इट कम्स टू फिजिक्स, जब हम फिजिक्स के बारे में बात करते हैं और उसके करियर्स के बारे में जब हम बात करते हैं, देन इट इज इम्पोर्टेंट टू अंडरस्टैंड दैट मोस्ट ऑफ द स्टूडेंट्स, जो ज्यादा करके फिजिक्स के स्टूडेंट्स होते हैं, वो रिसर्च परस्यू करते हैं. रिसर्च मतलब कंट्रीब्यूटिंग समथिंग न्यू टू द फील्ड बेस्ड ऑन द प्रीवियस नॉलेज. मतलब हमें जो अब तक पता है, वी कीप वर्किंग ऑन दैट, और हम एक्सप्लोर करते हैं कि what is it that we don't know, and we keep pushing those boundaries. That is what I call research. And apart from that, there are other career opportunities as well, which we would look ahead in the presentation. And speaking of, let's see, preparation, studies, and expectations. Yeah, and that's all for preparation of studies, expectations, and career. And again, when we speak of present preparations, we usually go for students in India usually go for JEE mains. They try to clear JEE mains and start studying Bachelor's of Science in Physics, and then they could specialize in something like astrophysics, astronomy, or they could go for biophysics or physical chemistry or material science and engineering. Those are related fields. I mainly wanted to conduct this session to explain this diagram because I think it really helps in understanding that what you truly want to do, and helps you explore like good career opportunities where it's a balance of interest and earnings. Because at the end of the day, when we think of career, we also have to like earn, and then we have responsibilities on ourselves that we have to fulfill. हमारी जो जिम्मेदारी होती है, हमें उसके साथ हमारे इंटरेस्ट को भी बैलेंस करना होता है. इसलिए I thought that this diagram would be good. ये chart अच्छा होगा. So what I try to explain is, here we have mathematics, statistics, and logic, and below that we have physics, chemistry, and biology. So when we think of physics, it's not only about studying the core concepts of physics, but you also need to have a good understanding of mathematics, statistics, and logic, along with chemistry. this makes physics studying a lot easier. मैं मेरे प्रोफेसर से कहता था कि physics is difficult and I might just drop it. And then he told me that find something that interests you and try to relate it with physics, and maybe then you will be able to like continue on that, and maybe you won't find it itna mushkil nahi hoga. Then I was like, yeah, I like astrophysics, so I was like, maybe yeah, I can study maths and physics, and that gave me astrophysics. अगर किसी को physics और chemistry में interest है, the career that they could go for is geophysics and physical chemistry, which deals with a variety of topics that are similar to astrophysics, and biochem and medical and medicine studies. For someone who is interested in chemistry and biology, what we recommend them to do is biochem, medicine, and medical studies. Because I was interested in physics and math, something जो मुझे एक और topic जो interesting लगता है जो math से related है is this thing called financial engineering, which I really like, and I thought that it could also be a good career. तो ऐसे सब हम explore कर सकते हैं. So at the end of the day, the question you need to ask is, what is it that you truly want to do? What is it जो आपको करना है? It is like, okay, you like physics, but what in physics do you like it? ऐसा what is the topic in physics that interests you? And then there are other tech topics that are similar to someone with interest in physics might like, which is computer science. Someone with physics can like computer science. They can like electrical engineering. They could like mechanical engineering, and they could also like civil engineering. So sometimes what happens is students say that they like physics, but what they truly want to do is hands-on stuff. They don't necessarily want to go for research. उनको मतलब रिसर्च में इंटरेस्ट नहीं होता है, उनको ज्यादा एक्सपेरिमेंट्स करने होते हैं, उनको हैंड्स ऑन स्टफ करना होता है, उनको बिल्ड करना होता है. They usually go for these engineering fields which also require a lot of physics, और उसमें भी बहुत सारा physics background आपको लगता है. And then there is, if you're interested in math, then there is data science and computer science, which are also good fields, and especially these have a lot of career opportunities. Because to succeed as a researcher in physics, you have to be exceptionally good at it, and there are very, very few people that are able to advance to those levels where they are truly at like the peak of physics when it comes to research. So it is very, very difficult to have a career in physics where you are truly among like the top researchers. Same goes for other natural sciences, because it is hard to pursue research in chemistry and biology as well. Of course, this is not to discourage you, but to let you know that yes, if you put in the effort, then yes, you can have a really good career in physics. And then for someone who is interested in physics and chemistry, they could also go for material science and engineering. So yeah, ये हमारे पास है. Yeah, if someone wants, they can take a picture of this, and then we can proceed. Other than that, there are other things which we, as humans, tend to have, which is like arts, which we all are interested in. And we often find that, okay, I need to find a balance of something that interests me, something where I can have a good career in, and something that will require understanding of science. So for someone interested in, let's say, someone interested in music could go for video editing and graphic designing. But because they are pursuing graphic designing and video editing, they might as well pursue computer science and then specialize in one of these fields. So this is how it works, and where you could find like a balance between things that interest you and things where you could have like a good career. And then apart from that, we also have natural language processing, which also requires a lot of math and science. And then this is also one of the blooming fields. And yeah, for physics, for someone interested in physics and mechanical engineering, especially someone who is interested in astrophysics, could also go for a career in aerospace engineering. And then, yeah, there are different fields. For example, we also have biotech and biophysics. Interesting, isn't it? And then these are some of the research topics that I wanted to discuss with you all. ये कुछ research topic है जो मतलब these have a lot of scope in future, because they are like novel topics, and there hasn't been much work into it, and these topics are still new, and there is a lot of work to be done in it. So one of my favorite topics is quantum computing, quantum information, and quantum communication. So quantum computing is in a very nascent stage right now. It's still new and there's a lot of work to be done, which is why I say that there's a lot of scope in it. Because with the recent advancements in science, it has become quite access. Quantum computers have become accessible. Maybe we have the Google Circ and we have IBM Qiskit, where you could run those simulations and you could take a take up a task of programming in one of the quantum computers and work on your own projects. And then we have quantum information, which is similar to quantum computing, but it's more theoretical, where you try to work on algorithms that you could run on quantum computers. And then we have things like quantum communication. So while I was at Stony Brook, one of my friends was working with a professor who was working on quantum communication, and they said that this has the potential to revolutionize our internet and connectivity through extremely high speed communication. So yeah, that is one of the fields that is quite that is booming. Next, we have superconductivity, and the importance of superconductivity is a lot when it comes to computing and medical, because as technology grows, so do the demand for hardware that requires to run the technology, which is why we are looking towards superconductors. And one of the research goal is to have superconductors capable of running at temperatures that don't have to be sub-zero, meaning they could run at warmer temperatures and reducing the cost required for cooling and making them safer. Another application of superconductivity is in medical fields. Uh, so when we speak of things like MRI machines use superconductors to make the scans and generate their results. And one of the tasks that I think that I will be taking up in the future would be working on superconductivity and to make sure that MRI devices are accessible to everyone. And that's what we are doing in our research by reducing the cost of MRI machines. Next up, we have quantum field theory, which is a part of high energy physics. So quantum field theory deals with the understanding how our universe behaves at quantum levels and then explaining the phenomena that occur at larger levels. For example, we have the standard model that explains things like fermions, which make up the matter, and then we have the bosons, which are the energy carrier, as some of us might know. And then we are trying to unify how we could make uh, general relativity and quantum mechanics agree with one another. And this is quite a challenging task, and quantum field theory has a lot of scope for someone interested in theoretical physics, where they do a lot of math. इसमें काफी ज्यादा मैथ लगती है, और अगर आपको है इंटरेस्ट मैथ्स में और if you're interested in physics, तो आप क्वांटम फील्ड थ्योरी वगैरह कर सकते हैं. There's a lot of scope in that. किसी को अगर experimental physics में interest है, so what they could do is they could go for neutrino astronomy. And there isn't a lot of work. इसमें ज्यादा अभी तक काम हुआ नहीं है, ये भी काफी नई फील्ड है और ये अर्ली स्टेजेस में है. Because what we are trying to figure out is to image early universe. हम ये देखना चाहते हैं कि जब बिग बैंग हुआ था, जो हमारी बिग बैंग थ्योरी है, what happened right after the big bang took place. For example, maybe something on time scales of hundreds of years. So what were the situations then, or maybe time scales of seconds? That's where neutrino astronomy helps us. Again, this is a very difficult field to pursue because, as the name says, it deals with a study of neutrinos. And as most of us or some of us might know, that neutrinos are particles that rarely react with matter and only interact with weak forces. And so it's kind of hard to detect. But one of the experiments that was done was the super Kamiokande experiment. And I encourage you all to look up. मैं चाहूंगा कि आप देखो super Kamiokande experiment, उन्होंने कैसे वो सेटअप किया था, and they were able to detect neutrinos. And yeah, and again, it's very difficult task, but yeah, but that's where like the beauty of physics lies in taking up challenging tasks and accomplishing it. because once we start working on this and there's like a milestone or a step towards advancement in physics, it helps people make their lives better because physics से हमें universe की understanding आती है. It helps us rationalize things. It helps us with the reasoning. जैसे कि हमारे in one of the previous sessions we were talking about how physics helps us fight things like superstition because whatever the reason could be, just physics helps us with those reasoning, and that's why it is important to have advancements in physics. Again, there's physics that is also applicable in the field of medicine. Again, that saves life. Again, which is why we need advancements in physics. Then there's another new field, which is machine learning for simulations. So I recently started doing a lot of simulations, and I started studying computational fluid dynamics. और मैं चाहूंगा कि अगर किसी को इंटरेस्ट है, अगर कोई प्रोग्रामिंग वगैरह में दिलचस्पी रखता है और उसको फिजिक्स भी करना है, this is actually a very good field where you have to do a lot of coding, programming, use all sorts of different libraries, you use all sorts of different systems to make simulations. And then there's also the machine learning aspect of it, which uses a lot of math. And again, as I said before, to study physics, you need to be good at math and related topics like chemistry. So this is also a very good field for someone who is interested in physics or someone who is interested in maybe computer science and they want to like enhance their skills of applied sciences or theoretical sciences, natural sciences. They could go for this thing, machine learning for simulations. I have quite a few friends who are working on this thing, and the stuff they do is quite impressive because without actually having to perform the experiment, you are able to get the results. That's just amazing. And then there's also compact objects where we study things like uh, neutrino stars, black holes, and then there are stellar remnants like white dwarfs and all the fancy stuff that comes into the topic of compact objects. Uh, I did study compact objects for some time, and one of the tasks that I was working on was how we could image black holes and exoplanets while I was taking one of the class, and it is also an interesting topic. It also requires a lot of computation, and it requires a lot of coding as well. Another new topic that I would say is quite quite untouched, like it's still in its early stages, is gravitational wave astronomy. Uh, I think the Nobel Prize, I think around 5 or 6 years ago, the Nobel Prize was awarded in this field, where they were able to detect the gravitational waves. And I think, again, this is quite amazing because it helps us detect objects that could not necessarily be in our sight, but we could sense their presence. Uh, so I was quite interested in this thing called gravitational astronomy. But what happens is gravity is quite a weak force compared to other forces. So I was talking to my professor, and we were talking how we could work on gravitational astronomy as a topic, and he said that the problem is again that the signals that we get are quite weak. So what we must do is to actually build these things called interferometers. If someone might have, some of you might have heard about LIGO. We need to build interferometers that are on the scales of kilometers. And what we proposed was, yes, we could build an outer spatial interferometer for that. Again, that's another field, and it requires a lot of understanding of engineering and physics. So ऐसा है, and then next we have our observational astronomy that includes exoplanets, and our tryst for our tryst for looking for life outside Earth still continues, and yeah, our curiosity still makes us look for exoplanets that could possibly habitat life. Then we also have renewable energy sources. This deals with more contemporary topics like climate change and energy crisis. And when you're pursuing something like renewable energy sources, you need to have a good understanding of chemistry, biology, and material science as well. And yeah, these were some of the research topics. Of course, there are a lot of different research topics, but these are someone that I think that have a potential in the future. And this is something that I know people who are working on it, and I think that this might interest someone who is interested in astrophysics as well. Uh, I think, yeah, all right. Yeah, so that it was quite short. I wanted to keep it short to leave room for questions. So if someone has questions, please feel free to put them in the chat, and we'll try to facilitate the question and answer sessions.
Yes, thank you so much, Malay. It was wonderful presentation. स्टूडेंट, आप अगर कुछ क्वेश्चंस और कुछ सवाल है तो आप पूछ सकते हो चैट बॉक्स में. सो he'll be happy to answer. सो आप अपने क्वेश्चंस को आप चैट बॉक्स में डाल सकते
I actually prepared something. So like I wanted to show one of the simulations that I was working on this afternoon.
हैं. Yes, go on, go on.
Right. So if we, let's see, let's go here. And then this is the Google Colab that I have created. And I found this online simulation that deals with fluid dynamics. Hi, Rohit. Can you see my screen?
Yes, it is visible, Balai. It is visible.
Yes, thank you.
Yes.
So what we are going to do is we are going to run a small simulation that deals with fluid dynamics. जैसे कि मैंने पहले कहा कि I started learning CFD a lot. So ये हमारे पास एक Google Colab notebook है. And what I'm going to do is, let's see if this runs. And then we are going to import everything. The star indicates that we are importing everything from PyFlow. And then we are going to set up our simulation. Then we are going to import libraries, and then we are going to plot our fields. So that's like one of the simplest simulations that I have right now to present. So what we are essentially doing is we are taking these functions and using them to plot this field that we have here. And then we could also make a simulation out of it. For example, we could use the trajectory parameter to simulate the evolution of those fluids. So this thing takes some time, and I think Google Colab, I think those interested in astrophysics or computational astrophysics, उन्होंने भी Google Colab try करना चाहिए. So we'll let it run for some time, and then we'll see what happens. Okay, so it says that it's done, and it took 20
Yeah.
seconds.
Yes,
then,
yes. Balai. Yeah. Yes, go on, go on, go on.
And then, yeah, this is the simple simulation we have where we are trying to show diffusion of the fluid. So not very, not very advanced, but I think this is like a good start for someone interested in computational astrophysics. Apart from that, I also have this thing. So if you don't know, this is Kaggle, and it is useful for learning data science. And one of my professors was working on a simulation, and this is the code that we have. And what this code essentially does is that it simulates black body radiation, and it gives output in the form of images. So if we go here, let's see. I have it advanced. So let's stop sharing. Let's stop sharing again. Share. Right, so if you all can see my screen, I have a MP4 file here which I made from a simulation. And if we just play it, and I'll explain what this does. So what we are doing here is that as the temperature rises, we are plotting the black body radiation that is given by an object and what part of spectrum this peaks. And again, this is quite useful when it comes to studying stars because we could look at the color of the star, the wavelength that it emits, and then we could use the spectrum to determine its surface temperature. And that is what I do in computational astrophysics. We are given the data for whatever the sensors give us, for example, the absorption spectrum or emission spectrum, and then we try to deduce the characteristics of the thing that we are observing. Isn't that amazing? I think this is quite amazing, actually having the ability to simulate what's going on out there. Yeah, so this was like another demo I had, and I thought that it might be cool to present. तो ये हमारा एक डेमो है जहाँ हम टेम्परेचर यूजिंग टेम्परेचर वी आर प्लॉटिंग द टाइप ऑफ लाइट.
Yes. So we have some questions. We have few questions in our chat box. So uh, Sonali Ahire, she wants कि आप थोड़ा सर प्लीज एक्सप्लेन द प्रिपरेशन इन करियर अपॉर्चुनिटी वंस अगेन. वो थोड़ा सा इफ यू कैन रिपीट वंस अगेन that preparation, how you prepared, and what are the career opportunities. So
Right. Can you hear me, Rohit?
yes, yeah, absolutely.
Right. So when I was preparing for my undergraduate, I did my undergraduate from Stony Brook University, and the exam I took was the SAT, and I took TOEFL because I wanted to go abroad because I thought that Stony Brook is a good place to study physics. And Stony Brook has a department called Yang Institute of Theoretical Physics, which is one of the best places on planet to study uh, astrophysics or theoretical physics. Apart from that, what I recommend for preparation, as I said before, हम JEE कर सकते हैं. JEE mains clear करके we could get into colleges in India. And if you want to pursue physics for your, let's say, for your masters, then what you can prepare for is called IIT JAM. I think JAM is joint admissions exam. And apart from that, there are also other institutes like Tata Institute of Fundamental Research, TIFR, that also assists a student with research. For example, there are different branches for TIFR. One is, I think, in Bangalore. One of them is in Mumbai, and other is in Pune. The one at Pune is for radio astronomy. And then there are other exams as well. There is JEST, JEST, that you could also take to embark onto like the research journey. And speaking of career, so career when it comes to physics, you don't actually have many career options when it comes to the type of things that you do. Um, Mainly those who pursue physics go on with their masters, then their PhD, then their postdoc, and they continue doing the research in whatever they were specializing in. So if you want to switch careers while you are studying physics, we could have a look at this diagram. Where let's say someone is interested in physics, they pursue physics, they could go for theoretical physics, or what they could do is they could go for computational astrophysics, and from there they could switch to computer science and data science. If you are interested in physics and you want to do more hands-on stuff, then what you could do is you could do electrical engineering, mechanical engineering, or civil engineering along with physics. So what I recommend is choose what you want to study, you continue with it, and then you pair it up with something that interests you, and that way you would be able to like have more career opportunities, and it makes easy to switch.
ओके, सो या आई होप कि सोनाली आपको अपने आंसर मिल गया होगा। सो मनोज वांट टू नो, मनोज जानना चाहते हैं कि what kind of entrance will required to be astrophysics, or what are the exams we can appear to be a astrophysics, or what are the procedure we have to appear, or you need to face to be in to be an astrophysics.
Okay, thank you for the question. So, what we could do is you could decide whether you want to continue in India or you want to go and pursue research abroad. So, if you want to continue in India, uh, I think what we recommend to most students is that they go for their JEE mains, they clear the JEE mains, and then they go for their advance. And if they are able to clear it, they could join the Indian Institute of Technology and then continue physics there. And while they are studying physics, what they could do is they could reach out to their department and let them know that they are interested in studying astronomy as well. And then you could switch to astrophysics as your specialization. Uh, and then there are other colleges, such as when it comes to studying abroad, because I think there's a lot of scope in doing research abroad because their infrastructure is quite advanced, and then you could learn, and then you could come back and help our infrastructure get better. So what you could do is you could take the GRE and then enroll for physics. And while you are studying physics, you could let your department know that you are also interested in studying astronomy, and then that makes up astrophysics. So you could look up to your college's website, or you could reach out to the dean of your college or the head of your department, let them know that yes, I am studying physics, but I'm also interested in studying astronomy. They would connect, hopefully, they would connect you with professors who are working in a similar field, and then they could guide you from there. If you are interested in working with one of the research institutes, they have their own entrance exam. I think JEST is one, and then there's CISR. I'm not sure about the name, but you could prepare for JEST, and you could take the JEST, and then you get to enroll with uh, uh, Tata Institute of Fundamental Research. And yeah, those are all the exams that I have at the moment. If we speak of what they should study at school level, so the syllabus at school level is predefined for someone who is studying physics. I think they have to go for physics, chemistry, maths. Some have to do biology, some have to do computer applications or IT. But your core has to be based in physics and mathematics. So you really need to be good with your understanding of mathematics, especially topics uh, things like calculus and multivariable calculus, because I was working as a teaching assistant at Stony Brook for physics, and what I found was students who are not who don't have a command over calculus will have a hard time pursuing physics. So yeah, you need to have a good understanding of yeah, topics in maths. Apart from that, what you need to also have understanding is applied geometry or applied real analysis, complex analysis, those topics. And what I would recommend is to start studying those topics before actually having to before your teacher starts teaching them, because what's that going to do is it would help you ask the right questions while you are in the lecture. It saves up time, and I think I found that strategy to be helpful as well, to actually study before actually going to the lecture.
Yeah, thank you, Valay. We have one more question. आनंद कुमार वांट टू नो, सर मिल्की वे गैलेक्सी को हम देख सकते हैं क्या?
I'm sorry, Rohit, क्या आप
क्या?
क्वेश्चन रिपीट कर सकते हैं?
He is asking like, can we see the galaxy, Milky Way galaxy? Sir,
Can we see
yeah,
Milky Way
yes,
galaxy?
Milky Way
So
galaxy.
So, I mean, so when it comes to observational astronomy, so the galaxy that we live in is Milky Way galaxy. So it's not actually possible to see the entirety of Milky Way galaxy, because that would mean that we would have to go out. But what we do know is that galaxies have these clusters of stars, and those we can see those clusters, which are like spiraling arms. So it's like it spins around a common center of mass. So we could see those spiraling arms on like a clear sky. So we don't actually see the full galaxy, Milky Way, but we could see parts of it.
So, so होप कि आप सभी को अपना जवाब मिल गया होगा. सो पर्सनली आई वांट टू नो भले कि
Yes.
व्हाट इंस्पायर यू, व्हाट मोटिवेट यू टू गो अब्रॉड फॉर योर अंडर अंडर graduation. You did your undergraduation from that same
So,
university, right?
yes, I did my undergraduate from Stony Brook.
So
Yes.
what motivated you to go there for your graduation?
So initially, I wasn't planning on going abroad because even like most students, I didn't know like it was possible as an undergraduate to do that. But after completing my 10th grade, I switched school. I went to a different school and I also changed my curriculum. So while I was until 10th, I was in ICSE, and I also did, I switched to Cambridge after 10th. And then I got to know that, yes, you could take these entrance exams. And what encouraged me was the idea of research. I was always interested in doing like research and contributing and making original contributions based on our current knowledge. And I looked up, and I also had a few friends from school who were interested in doing so. Then we also had counseling sessions within the school, and that's how I navigated. And again, speaking of interest was because Stony Brook's research infrastructure is great, and that's what enticed me. Because it's very difficult. Like honestly, it is very difficult to get research positions within India because there aren't many investments going on. Of course, there are changes, but currently there isn't much investment going on compared to something like the West, the United States, or the European nations, any of the European nations. So that's why I wanted to go there because again, I wanted to learn from there, come back and contribute here.
Okay, that's great. Thank you, Vale. So how about your scholarship or funding? Did you apply or you got the full fund?
So when I was applying for scholarship, I didn't get full funding. I got partial funding, and partially it was through from my family and through education loan. And I was also working on campus, as I mentioned before. I was working as a teaching assistant, so that gave me the credit hours. And I was also working as in different offices. I was also working in visa and immigration, and I was a part of the student government, so that helped me like fund part of my studies. So yeah, it's always nice to have on-campus jobs, especially if you have something like a research assistant. Then it's great.
It's great. Yeah, it's so. I want to know, Malay. So what kind of suggestion do you want to give our students, those who are already in their 12, or they want to go abroad for their undergraduation? So,
Okay. No, like I wish someone had told me this that how difficult it is to continue with research because it is very tiring because it takes a lot of hours and my expectations weren't set clear. So what I often tell the students who come to me saying that they want to pursue astrophysics is it's a big commitment. It's like let's say you are in your 12th grade, you are preparing for the entrance exams, maybe you are preparing for JEE, or maybe you are preparing for exams. We have the MHCET, the Common Entrance Exam, or CUET, KVPY, all those exams. And once you start working on physics, it would take at least, let's see, so 4 years for undergraduate, 2 or 3 years for your master's, and maybe another 5 years for your PhD. So it takes a good 5 6 years until you can see something tangible in your life. And another suggestion I usually give is that so when you are studying physics, it's quite important to have like a solid base and a solid foundation, as I said before, for topics related to mathematics. And you should spend a lot of time actually working on like the first principles of mathematics and not just trying to get the right answer, but figuring out ways कि it's correct. मतलब, what I think and what my friends pursuing physics think is that correct answer is like ये अगला पार्ट होता है. What you have to do, जो हमें उससे पहले करना है, is correct answer लाना कैसे है. That is the challenge. Correct answer, once you know कि हाँ ये steps आपको लेने हैं, then the answer is वो that is not a problem. The problem is figuring out a solution. तो तुमको मतलब you have to not just work on like understanding the topics, तुमको इस पे भी काम करना पड़ेगा कि how आप ये कैसे कर सकते हो कि आप प्रॉब्लम सॉल्विंग में कितने अच्छे हो, आप प्रॉब्लम सॉल्विंग कैसे करोगे. That is more important because let's say अगर आप फर्स्ट ईयर, ठीक है, आप अगर फर्स्ट ईयर फिजिक्स कर रहे हो, देन आपको मतलब थोड़ा सा रिवीजन वगैरह होता है, जो बेसिक आपने पढ़ा होगा जेई वगैरह में, वो थोड़ा आपको फर्स्ट सेमेस्टर में आएगा, उसके थोड़े एडवांस प्रॉब्लम आएंगे आपको. बट उसके बाद यू आर ऑन योर ओन. फिर प्रोफेसर आपको बस पढ़ाते जाएंगे, पढ़ाते जाएंगे, पढ़ाते जाएंगे. ऑफ कोर्स आप उनसे सवाल करोगे, उनके ऑफिस आवर्स वगैरह होते हैं, आप उनसे बात करोगे, वो सब होगा. बट एट द एंड ऑफ द डे आपने कितना टाइम स्पेंड किया वो मटेरियल पे बाय योरसेल्फ and understanding the material. I think that is more important. And I think, Rohit, you also studied physics and you can also relate to this key.
Yes.
Apart from the professor, you also have to like spend time, a lot of time. आपको बहुत टाइम देना पड़ता है रीडिंग के लिए, आपको रिसर्च पेपर वगैरह ढूंढने पड़ते हैं, पढ़ना पड़ता है. तो आपको मतलब एक टॉपिक पढ़ने के लिए 10 अलग किताबें खोलनी पड़ती है, तब जाके आपको एक टॉपिक समझ में आता है. That is like the challenging part, and I think we must all be prepared for that for someone who wants to, जिसको अगर फिजिक्स पढ़नी है तो, कि पढ़ाई तो बहुत करनी पड़ेगी, किताबें किताबें और पेपर तो बहुत पढ़ना पड़ेगा.
Yeah, that's true. That's true. So thank you so much, Valay. Thank you so much for having today as our mentor. So it was such a wonderful session. So जो स्टूडेंट्स आप अगर एस्ट्रोफिजिक्स में आप अगर इंटरेस्टेड है और आगे आपका करियर बनाना चाहते हो, तो यू कैन contact Balay Salve through our Nalanda STEM yeah, Nalanda Counselling Center. So we can recontact with Balay अगर आप इंटरेस्टेड है और आगे करियर बनाना चाहती हो, तो भले आपके हेल्प करने के लिए he'll be happy. So you can connect with him. So thank you so much, Malay, for this wonderful sessions.
Thank you,
And
thank
we
you, Rohit.
hope कि आगे ऐसे सारे बहुत सारे sessions we can have in future, near future. So it was very wonderful, and we are very happy to have you here as our mentor.
Thank you.
So I think we do not have any questions in our chat box. So I think hope students आपको आज के सेशन से बहुत सारे कुछ सीखने को मिला है, एंड आपके पास है हमारे दोस्त भलय, सो ही कैन गाइड यू अगर आप जाना चाहती हो, एब्रॉड जाना चाहती हो और एस्ट्रोफिजिक्स में आप करियर बनाना चाहती हो. सो आई थिंक फॉर टुडे दैट्स ऑल.
Okay, thank you, Rohit. See you.
या